Continuing from our previous tutorial, we've exported our map using the QGIS2 web plugin. Now we need to access those files. The plugin saves everything to a temporary folder that we can't work with directly, so let's navigate to it. We're going to Local Disk, then Users, our user account, App Data, Local, Temp. And finally, the QGIS2 web folder. Here's our exported web map. Let's copy this entire folder to the desktop, where we can actually modify and work with the files without any restrictions. Now that we have our working copy on the desktop, let's open the folder and launch the index file. This opens our interactive map in Chrome, showing us the base map we created in QGIS. This is what we'll be adding our live ESP32 temperature data to. Next, we need to set up our ESP32 to run as a web server. I'm opening the provided code file called ESP32DHT11 WEBSERVER in Thonny. This code will allow our temperature sensor to broadcast data over our local network. First, we need to update the GPIO pin number. The default code uses GPIO4, but our DHT11 sensor is actually connected to GPIO18, so let's change that. Second, we need to configure the Wi-Fi credentials. I'm entering our network name and password here, so the ESP32 can connect to the same network as our computer. These two changes ensure the hardware matches the software configuration. Time to upload this to the ESP32. Opening Thonny, I'll go to Run, then Configure Interpreter. Let's verify our USB connection and COM port are correct. Now I'll paste our modified code and hit Run. The ESP32 is connecting to WiFi and starting the web server. Perfect. Here's our IP address. This is the network address where our ESP32 is now hosting temperature data. Let me copy this IP. We'll need it in just a moment. Now comes the key integration step. I'm opening a new JavaScript file and pasting in code that will fetch data from our ESP32. On line 8, I need to replace the default IP address with the actual IP we just got from our ESP32. There we go. Now this script knows where to find our sensor data. Let's save this file. I'm naming it ESP32-overlay.js and saving it directly into the resources folder of our copied QGIS2 web map. This JavaScript file will run in the browser and pull live temperature readings onto our map. Let's check the resources folder to confirm our new JavaScript file is there. Now let's see if anything's changed. Opening the index file in Chrome again, and as expected, nothing's different yet. That's because even though we created the overlay script, the map's HTML file doesn't know to load it. We need to link these together. I have the final piece here, a script tag that tells the HTML page to load our ESP32 overlay. Let me copy this line. Now I'm opening the original QGIS index HTML file in Notepad. I need to find the right spot to add this. Scrolling down to the bottom, here are all the other script tags that load various map functions. I'm going to add our ESP32 overlay script tag right here, just above the closing body and HTML tags, but below the existing scripts. This ensures our temperature overlay loads after the base map is ready. Let me run the ESP32 code one more time in Thonny to make sure the server is active. Opening the HTML file, pressing F5 to refresh, and there it is. A red marker has appeared over Edmonton, displaying the live temperature reading from our DHT11 sensor. We've successfully integrated real-time sensor data from our ESP32 into an interactive web map. The sensor is broadcasting over Wi-Fi. The JavaScript is fetching that data, and the map is displaying it geographically.